So in this lecture, this is the shaft here, and this shaft is rotating inside the journal. We have to calculate the torque and power loss. So how to calculate, we'll see that. So this is the shaft here, this is the shaft, and here the shaft radius, that is r. Okay, this is small r, this is the shaft radius. Okay, and from shaft center line to this wall, so here the distance, that is capital R. Okay, and this here, this wall to shaft outside diameter, this is known as clearance. Okay, this is known as clearance. So and the angular velocity, that is the omega, and this length, that is small l. Okay, and here there is a point A, B and C. Okay, so same view here. So this is the vertical position. So this is the length here, this is L, and here also L, and angular velocity omega, this is radius smaller, and here the total center line to wall, this capital R. We know that V equal to R into omega. Okay, and how to calculate clearance? That means, so here clearance, so that is R minus R. So this distance, total distance minus this distance, so that will be the clearance. So H equal to R minus R. Okay, so point A, point B, point C. So velocity of point A equal to velocity of point B equal to velocity of point C. V equal to, we know that R into omega. So here the distance, that is radius R, omega is the angular velocity omega. Okay, so if you want to calculate the shear stress tau, that is, we know that mu into V by H. So mu into V equal to, we know that R into omega. So mu R omega by H. F force, that is equal to tau into area. So tau, we know that, and area, so what is the area? That is the outside area. So here what is the circumference? 2 pi r. So 2 pi r into this length. Okay, 2 pi r into L. So the circumference of the shaft into this length. Okay, so because lubrication in between, in this zone. Okay, so that's why this length multiplied by. So if you want to calculate the torque, TF, that is equal to FF into R. Okay, force into distance, we know that. So this is the torque. Okay, so TF, torque, that is equal to tau. So here tau into 2 pi r L. So tau into 2 pi r L into R. So TF, that is equal to tau, that is equal to mu R omega by H. So here mu R omega by H into 2 pi r L into R. So from here TF, that is equal to 2 pi mu R cube omega L by H. 2 pi mu is the viscosity, R is the radius of the shaft, omega is the angular velocity, L is the length, this length. Okay, and H is the clearance. Okay, now if you want to calculate the power loss, so power loss, that is equal to TF into omega. So this is torque into omega is the angular velocity. So this is the formula of this question. Okay, so now try to solve one problem that is very important for gate point of view. So here a journal bearing has a shaft diameter of 40 mm. So here the diameter, that is 40 mm, and length of 40 mm. So if the diameter is 40 mm, so what is the radius? That is 20 mm, and if you convert it mm to meter, that is 0.02 meter. And here the length is 40 mm given in the question, so that is equal to 0.04 meter. Okay, the shaft is rotating at 20 radian per second. So here omega, that is 20 radian per second. Okay, and the viscosity of the lubricant is 20 micro pascal second. Okay, so 20 into 10 to the power minus 6 pascal second. The clearance H is also given, that is 0.02 mm. So 0.02 into 10 to the power minus 3 meter. So you have to calculate the loss of torque due to viscosity of the lubricant is approximately. So you have to calculate the torque. So from this formula we know that torque, that is equal to 2 pi mu r cube omega L by H. So here TF, that is equal to 2 pi mu r cube omega L by H. So try to put the value here. So 2 pi into mu, that is 20 into 10 to the power minus 6 into r cube, that is 0.02 whole cube. So r is the this 0.02 whole cube into omega, which is also given 20, L, that is 0.04 divided by H, that is equal to 0.02 into 10 to the power minus 3. So if you calculate that, the answer will be 4.02 into 10 to the power minus 5 Newton meter. Okay, so same type, there is also the same type of question here, same type. This is also important question. This is the previous year gate question. Important question. A journal bearing has a shaft diameter of 40 mm. So diameter is given, so radius will be 0.02 meter. Length, that is 40 mm. So L, that is equal to 0.04 meter. The shaft is rotating at, so omega is given, and the viscosity is also given. So this is millipascal second. So milli, that is 20 into 10 to the power minus 3. So 10 to the power minus 3 due to m. Okay, the clearance is 0.020. So H, that is equal to 0.020 into 10 to the power minus 3 meter, because this is here m unit. So when you solve the question, try to focus on the unit also, otherwise your answer will be wrong. The loss of torque due to viscosity of the lubricant is approximately. So you have to calculate the torque. Okay, so if you put the value, so here the torque will be 0.04 Newton meter. Okay, easy question, no problem, huh? Okay, try to understand this question. So a lightly loaded full journal bearing has journal diameter, so diameter is given, so what is the radius? That is 0.025 meter. Bush bore of 50.05 mm. Okay, so from here you can calculate the H, and bush length of 20 mm. So L, that is equal to 0.02 meter. Angular speed, that is RPM. So N, that is equal to 151200. So try to solve this question, similar question. Okay, so another this, try to understand this this also same concept. Here the shape, the area is decreasing from this to this. So here the length is L and angle is theta, and at R location the distance is H from here. So V equal to R into omega dl, R plus dr. So for that case, how to calculate the torque? Okay, same as this. So try to understand that. So this is my handwritten notes. You can download it from the description. The PDF link is available on the description. Okay, so now let's try to understand the units of viscosity. So tau, that is equal to Newton of law of viscosity. We know that tau equal to mu into du by dy. So from here mu, that is equal to tau upon du by dy. So we know that the unit of tau, that is Newton per meter square, and du, u unit, that is meter per second, and y, that is meter. So from here Newton second per meter square. Okay, so Newton means kg meter per second square. Second, this second by meter square. From here you can get kg per meter second. Okay, so this there is for SI unit. So Pascal second you can say that, or you can say that Newton second per meter square, or kg per meter second. So this type of question directly asked in the SSC JEE exam. Okay, so for any competitive exam, easy competitive exam, this type of what is the unit of viscosity. Okay, and what is the CGS unit? So 9 second per centimeter square, so gram centimeter second. So this is poise. Okay, and what is the relation between poise and SI unit and CGS unit? So 0.1 Pascal second, that is equal to 1 poise. Okay, so this is also very, very important. So star means this is very, very important. Okay, now the unit of kinematic viscosity. So kinematic viscosity, we know that viscosity by density. Okay, so what is the unit of viscosity? We know that from here, that is kg meter second, or you can say that Newton second per meter square, or you can say that Pascal second. So consider this is kg meter per second. So here this is kg meter second, and rho density, that is kg per meter cube. So from here you can get meter square per second. So this is very, very important. This is also asked in directly in SSC JEE exam or other competitive exam. So nu, that is the symbol of kinematic viscosity, that is equal to meter square per second, or for this is the SI unit, and CGS unit, that is centimeter square per second. Okay, it is also known as stroke. Very, very important CGS unit of kinematic viscosity, that is strokes. Okay, thank you.